Hey, ladies and gentlemen, welcome to 6-2. Today we're going to do permutations and combinations. All right, so again, this is review from Algebra 1. We're just reviewing it. Sometimes we might be throwing in a little more new stuff. All right, so when the manager of a softball team fills out her team lineup card before the game, the order in which she fills out the names is important because it determines which order the players will bat. Suppose that she has 7 possible players in mind for the top 4 spots in the lineup. Using the fundamental counting principle that we learned in 6-1, how many ways can she assign players to the top 4 spots? All right, so how many does she have to choose from? Well, she has 7 total to choose from, and she has 4 spots that she is filling. So she has 7 to choose for the first spot. Now she's used them, so then she only has 6 left here, 5, and 4. And so then we multiply that with our fundamental counting principle. And we get 840 ways that she can make that lineup occur. All right, so we're going to talk about permutations first. Permutations say when a group of objects or people are arranged in a certain order, the arrangement is called a permutation. So order is important. A, B is different than B, A. So this ties back to our previous example. Our previous example was a permutation. The batting order makes a difference. If you have Sally going first and you have Jane going second, that's different than Jane going first and Sally going second. So we have our permutation formula here, and it's going to use our factorial. That's what that exclamation point is used for. Remember, factorial is going to be, if we have 5 factorial, it's 5 times 4 times 3 times 2 times 1. From that number, multiply all the ones below it, all the way down to 1. So our permutations formula is n factorial, the number of objects we are taking, over n minus r factorial. And the r is how many, that's our total choices is n, and how many we are choosing is r. All right, so let's look at our first example here. It says, there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? All right, so we have 10 people total, so that's our n. And we are choosing 3 of them, bronze, gold, and silver. So that's our R. It's important to note that when we're arranging these skaters in first, second, and third position, so if you get awarded a gold, it's different than you being awarded a bronze. So we're going to say 10 factorial over, and now in parentheses, 10 minus 3, close parenthesis, and then the factorial. So the denominator is going to become 7 factorial. So we can actually look at this out by hand. 10 times 9 times 8 times 7 times 6. Ooh, I hope I don't run out of space. 5, 4, 3, 2, and 1. Whew. All right, all over 7 factorial. 7, 6, 5, 4, 3, 2, and 1. So we know with fractions, if I have a number in the numerator and the denominator, I can cancel those. Those are going to reduce down to 1. And so we're left with 10 times 9 times 8, which is if we were using our fundamental counting principle. So they're seeing our formula, they're doing it out by hand, and also relating back to our fundamental counting principle. Now, if you have a graphing calculator, you are capable of putting this in your calculator. So some calculators, you're going to have to put it in like this. And then other ones you see in the form like this. So if you have your graphing calculator and you have a Texas Instruments one, a TI, it doesn't matter what version, if you push the math button and arrow over to PRB or PROB, you'll see it underneath that one. I think permutations, combinations, and factorials are like 2, 3, and 4, or 3, 4, and 5, one of those. All right, so take a look there. Oops, skipped one. All right, a newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? So I'm assigning them to a specific person. So my N is, 9, not 8. And I'm assigning 4 of them, so that's my R. So 9 factorial over 9 minus 4 factorial. So you can type that into your calculator, you can do it out by hand, or you can type into using your permutations formula in your calculator. So I'll give you a moment here to do that calculation. Okay, so you should end up with 3,024 different ways that they can be assigned a story. All right, how many different ways can letters be arranged in the word geometry? Okay, so we have, this one is still a permutation, but we are going to look at it a little bit different. How many letters are in the word geometry? Well, there are 8 of them. And we have to remember, we have to divide out by any repeating values. Okay, so our repeating value is our E. We see that repeats twice. So I'm going to divide by 2 factorial. So really, what we're seeing is we have a permutation. We have 8 total letters and we're choosing them. And we have to divide it out by, I have 2 vowels and choosing those 2 vowels. So if you type this into your calculator, you are going to find out you have 20,160 different ways that that could be rewritten. So permutations with repetitions, and you've got this little box here in your notes. It says the number of permutations n of n objects of which p are alike and q are alike, n factorial divided by p factorial, q factorial. And that's what we saw right up here that we looked at before. Just a reminder that p and q are repeated values. All right, so let's go ahead and look at another one. It says, how many ways can the letters in the word Mississippi be rearranged or arranged? All right, so first off, you need to count how many letters are in the word Mississippi. All right, good. There's 11 of them. And then I definitely have repeats here. We have how many I's? 1, 2, 3, 4 I's. So 4 factorial, and 1, 2, 3, 4 S's, so 4 factorial, and then 2 P's, so a 2 factorial. Now, just a reminder, when you are typing this into your calculator, it's very important that you put parentheses around that denominator. Otherwise, your calculator is taking 11 factorial and dividing that by 4 factorial, and then it's taking that value and times it by 4 factorial and 2 factorial. You don't want that to happen. You want all of the multiplication to occur first, and then that division to occur. All right, so you should end up with 34,650 different ways that that could occur. So let's talk about combinations on the backside. Combination, it's an arrangement or a selection of objects in which order is not important. It's called a combination. So not important, B is the same thing as B times A. So the Vikings playing the Packers is the same thing as the Packers playing the Vikings. They're both still in the game playing against each other. So we have a little bit different formula here. We see right here is our combinations formula. Now notice this is very similar to the permutations one, but the only difference is now we add on this R factorial. And that is what helps delete out those repetitions, just like we saw on our previous problem where we divided by repetitions. All right, so let's go ahead and look at an example of a combinations problem. A group of 7 students are working on a project and it needs to choose 2 students to present to the group's report. So it doesn't matter if you're picking Jim then Sal or Sal then Jim, okay? So this is a combination. Oops. All right, so, here, they even give us some names. So if Sam, Ella, and Marissa, and Katie, Tyson, Scott, and Kevin are working together, Sam and Ella is the same to presenting as Ella and Sam. Order doesn't matter. That's why this is a combination. All right, so I have 7 for my N and 2 for my R. 7 factorial over now in parentheses, 7 minus 2 factorial, and then another 2 factorial. So just like my permutations ones, I can do these out by hand. This will turn into 7 factorial over 5 factorial, 2 factorial. So 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1, and then another 2 and a 1. So my 5, 4, 3, 2, 1 will cancel, and then I have a 7 times 6 over a 2 times 1. Well, I can actually reduce the 6 down to a 3 with that 2. So I get 7 times 3 over 1, so I have 21 different choices that I can have partners. So notice combinations is significantly less for choices because, you know, AB is the same thing as BA, so that counts as one choice instead of two. All right, so 5 cousins at a family reunion decide that 3 of them are going to go pick up pizza. How many ways can they choose 3 different people who will go? So does the order matter in which they go? No, it doesn't. You're just picking a group of 3 people. So we have a combination. We have 5 to choose from, and we're choosing 3 of them. 5 factorial over 5 minus 3 factorial, 3 factorial. So this is going to simplify into 5 factorial divided by 2 factorial, 3 factorial. So go ahead and type that into your calculator, use your formula, etc. Just a reminder, these go in parentheses. All right, so you should end up with there's 10 total possibilities for that to occur. All right, 5 cards are chosen from a standard deck of cards. How many hands consist of 3 clubs and 2 diamonds? So does it matter the order that you choose your 3 clubs? No. 3 clubs, if we choose 4 of clubs, 7 of clubs, and 8 of clubs, that's the same thing as choosing 7 of clubs, 8 of clubs, and 4 of clubs. Order doesn't matter. So this is a combination. But we now have multiple events. We have choosing 3 clubs and 2 diamonds. So if we see the word and, that means I'm going to have multiple combinations set up here. Okay, so let's talk about for choosing 3 clubs. How many clubs do I have to choose from? Well, how many clubs are there total in a deck of cards? There are 13 of them. Remember, 52 cards, 4 suits, 52 divided by 4 gives us 13 total clubs, and we are choosing 3 of them. When we see the word and, that means it's a multiplication problem. 2 diamonds. Again, it's a combination. How many total diamonds do I have to choose from? 13. And I want to know about choosing 2 of them. So again, this is the number of clubs. This is how many I'm choosing. Okay. So you can type it into your calculator. You can write it out in your formulas. You can do all sorts of those. Go ahead and do one of those methods. All right, if you haven't gotten it done, pause. Otherwise, your answer should give you 22,308 for that. All right, 7, 6 cards are drawn from a standard deck of cards. How many hands consist of 2 hearts and 4 spades? Again, we're talking about multiple events here. Multiple events. And, all right, 2 hearts. So it's a combination, because it doesn't matter if I choose the Queen of Hearts and the Ace of Hearts, or the Ace of Hearts and the Queen of Hearts. So I have 13 hearts, and I'm choosing 2. And, so I multiply. I have 13 spades, and I'm choosing 4 of them. Go ahead and try that out in your calculator. It doesn't matter. And you should end up with 55,770 total different ways that that can occur. Whew, that's a lot. So let's go ahead and it says try one more. Let's make a little more space for this though. Because this one says 6 cards are drawn from a standard deck of cards. How many hands consist of 2 cards from one suit and 4 cards from a different suit? Now this is a totally different type of problem because we aren't given a specific suit to choose from. So not only is choosing the 2 cards an event, but also choosing a suit is an event. So we are not going to have just 2 events occurring here, but we have 4 events occurring here. Choosing a suit and then 2 cards from that suit, choosing a different suit and then choosing 4 cards from that suit. All right, so we have how many suits in a deck of cards? Well, there are 4 suits and we're choosing one of them. So this is, think about this as choosing one of four possible suits. Okay, it's an and. Now, and out of that suit, we are going to choose two cards. So that's 13 cards in that suit, doesn't matter which suit, and we are choosing two out of there. Okay, then we are picking a different suit. Now, we only have 3 suits left because we've already chose one. So choosing one suit from 3 remaining. That is totally missing letters in remaining. Let's try this again. Remain. There we go. And then out of that suit, we have 13 cards in that suit, and we're choosing 4 from there. All right. So again, type it into your calculator using your permutations, your combinations formula. You can write it out by hand. You can go ahead and use your shortcut. All of those are going to work in this. So you get multiple ways to get to the same answer. So when you get this answer, you should have 669,240 different ways to choose 2 cards from one suit and 4 cards from a different suit. All right, ladies and gentlemen, there you go. You have the notes complete, and we'll see you later.